The two basic types of energy that you should know are kinetic energy and potential energy. Kinetic energy is energy associated with a moving object. As an object's speed increases, its kinetic energy will exponentially increase. Potential energy is used to describe stored energy or the potential to do work. Let's say that a 5 kilogram ball is thrown at a speed of 10 meters per second. We can calculate the kinetic energy by taking 1/2 of the mass times the velocity squared. Using this formula, we find that the kinetic energy of the object is 250 joules. We see that as an object's mass and velocity increase, the kinetic energy will also increase. However, because the velocity is squared, an increasing velocity has a higher overall impact on the kinetic energy. Now, what if instead this same object was not moving but was positioned at a height of 5 meters above the ground? This would be an example of potential energy. And we can calculate this by multiplying the mass, the acceleration due to gravity, and the height of the object. Using the potential energy formula, we find that the potential energy of this object is 245 joules. The potential energy of an object will increase linearly as the mass or the height increases. An important concept to understand is that energy must always be conserved. If the energy of an object increases, it will need to come from a decrease in energy somewhere else. And if the energy of an object decreases, that energy will also need to go somewhere else. A roller coaster is a perfect way to demonstrate the conservation of energy. As an example, let's say that you wanted to find the velocity of the roller coaster at a certain point on the track. If we know the starting velocity of the roller coaster as well as its mass and the change in height, we can find the change in potential energy and use this to calculate the roller coaster's speed. We know that the change in potential energy will be equal to the mass times the acceleration due to gravity times the change in the height. Plugging in 200 kilograms for the mass, 9.81 meters per second squared for the acceleration due to gravity, and 7 meters for the change in height, we find that the change in potential energy is equal to 1,373.4 joules. We know that the formula for kinetic energy is 1/2 of the mass times the velocity squared. We know that any decrease in the roller coaster's potential energy will be converted to kinetic energy, so we can plug in 1,373.4 joules for the kinetic energy. We can plug in the mass since that won't change, and then the only thing we need to do is solve for the velocity. Taking the square root of the velocity squared, we find that the velocity of the roller coaster at this point is 3.7 meters per second. This is assuming that the initial velocity of the roller coaster was 0. If it was something else, we would just add this answer to the initial velocity to find the final velocity. I hope that this video clearly showed you the difference between potential and kinetic energy, and also demonstrated the concept of conservation of energy. While these problems can get pretty complex, these are really the basics of what you need to know. Using this information, you should be able to solve a wide variety of different problems. If this video was helpful, please give it a like and consider subscribing to the channel. And as always, comment below if anything was unclear. Thanks for watching.